Today's topic is permutations, but before we get to permutations, we have to learn what something else means, because it's part of a permutation, and to understand a permutation, we got to know this part first. So the first thing I want to talk to you about is the operation of factorial. Factorial, F-A-C-T-O-R-I-A-L, factorial. And the symbol is an exclamation point. That's the symbol. And so, what does it mean? It means take the number. You don't need to mark that. I'm just trying to get you to focus where I'm looking, where I'm talking about. And multiply it times the next lowest number, and multiply it times the next lowest number from that, all the way until you reach 1. Okay, so that doesn't mean a whole lot to you, but if you look at our example, 5 factorial means 5 times 4 times 3 times 2 times 1. That's 5 factorial. Okay? And look, you can sit there and do on your calculator 5 times 4 times 3 times 2, and you don't have to do times 1 because that's kind of boring, but you could. Or you can find the factorial button. So your button will look something like that. It'll either just be the exclamation mark, nothing else. It'll be N exclamation point or X exclamation point. So everybody find your button. You have it. Some of you have to look in a menu to find your button. You have to go to a statistics menu. So you got to learn your calculator. You got to find your button. Everybody's got the button. So everybody find your button, and when you find it, punch in 5 factorial and see what your calculator tells you. So everybody's got to find it, and you got to figure out how to use it. Somebody raise your hand and tell me what 5 factorial is. Omar? 120. It is 120. Have you found the button? Has anyone not found their button? Okay. Aaron, everybody look, hold up your calculator. Anybody have a calculator like Aaron? Hannah, you do? Did you find yours? Okay, so that kind we got to find. Kristen, hold up your calculator. Okay, no one's going to have a calculator like that. She's got a graphing calculator. There's a menu in there for doing probability and statistics, and you have to find the factorial button in that menu. Lots of luck. But you can find it. It's in there. So that's where you got to go. Chloe, what calculator do you have? Hold that up higher. I think someone's going to have a calculator like that. Did you find it?
It's on the 3. You have to do the second button, and then you press the 3.
See it above the 3? So second and 3 is your factorial. Who else is still looking for factorial? Let's hold up your calculator. Show it to the crowd. Anybody have one like hers? Do you know where it is, Allison? Tell her where yours is. Who else hasn't found it yet? Julia, hold up your calculator. That's similar to Kristen's, isn't it? So you have one similar to Kristen. Who else hasn't found it? All right, hold up your blue one. I know other people have a calculator. Show the class. Who's got one like Amber? Have you found it, Nathan? Oh, this one is right there. It's going to be right on the thing. I think yours is in stat or in data. No, not in stat, not in data. Oh, PBR. PBR button. Okay. Your PBR button, it's the third one. You gotta go move to the third. You gotta hit enter. I think you gotta tell it how many. Or maybe you gotta do the 5 first. So 5, so clear it. 5. PBR button, go to factorial, third one, and then hit enter. Whoa. Just told you 5 factorial was 144,000. 14,000. Again, the other thing with your calculator is you got to figure out how it wants you to input the data. Okay, yeah, I don't know what I did the first time. So that's got yours. Did you find yours? Okay. Who else still needs to find theirs? Anybody have a calculator like Erin? So why don't you show Erin how to find hers? You can get out of your sheet. And let's see on this one, yeah, you are definitely going to be in a menu.
I pressed there's no menu, there's loads. I'm looking to loads.
I think you're going to be in statistics. Oh, you're right. You don't even have any battery power. You can't even read it. You need another calculator. Get yourself a normal calculator, all right, like everybody else. These days, they're very cheap, like less than $10 at Kmart or Walmart or CVS or whatever. Right, so you're not, what button are you thinking you're hitting? That, okay, that white is right. The white is the third. 5, third, that. Okay? White is your third. Everybody else except Kristen have it now? Hold up your hand if you do not have it yet. Didn't somebody how? You got the other weird one? Oh yeah, lots of luck. But you know, honestly, for pre-algebra, you need to get a more normal calculator than a graphing calculator. It's a big menu. It's just a big menu, Julia. You should ask Mom to get you a more simplistic scientific calculator. Julia, you hear me? I'm talking to you. You should ask Mom to get you a more simplistic. What's up, Colby? All right, so again, you got to find your button. That is really, really key. So go ahead and punch 8 factorial. Let's make sure we're working our button correctly. And you see it gets to be a big number quickly. If I ask you to explain 8 factorial, I'll expect you to say 8 times 7 times 6 times 5 times 4 times 3 times 2 times 1. If I just want the number, you're just punching it in your calculator. Brendan, you are writing notes, right?
Yes.
Okay. You do have your calculator, or you're just ahead your... All right. So now let's get to permutation. A permutation is an arrangement of a group of objects in a specific order. In a specific order. So that's a permutation. It's objects listed in a specific order. Now, usually I have people come up and stand in order, but I'm just going to do it here on the screen. So, let's suppose we have 3 people, and let's go, we'll call it person 1, person 2, and person 3. A permutation is, in how many different ways can we arrange these 3 people that'll give us a different order? So what do you think? How many different ways can we arrange 3 people? How many different orders can we get out of 3 people? Edward?
6.
Okay. What else? Anybody think something else? Kristen? 9. What else? Omar? 9. What else? Anybody else? What do we get? 6 and 9? Would you have anything else besides 6 and 9? How many are 6 people? I think there's 6. How many think there's 9? Okay. So if you treat this like a general situation like P times Q, then you're going to be in trouble. So here's the situation. We can have 1, 2, 3, that's one order. We could have 1, 3, 2, that's a second order, isn't it? We could have 2 in the front and then have 1, 3, that's a third order. We could have 2 in the front and have 3, 1. That's a fourth order. We can have 3 in the front and then have 1, 2. That's a fifth. And then we can have 3 in the front and have 2, 1. And that's a sixth. And the answer is 6, but not because you multiply 1 times 2 times 3. That's not the reason. If I were to use the numbers 7 and 8 and 9, there'd still be 6 ways you can arrange those 3 numbers. If I had Bob and Sally and Susan, there'd be 6 ways I can arrange 3 objects. That was the point. How many ways can I arrange 3 objects? That's a permutation. How many ways can we arrange 3 objects? So, All right. Windows doing strange things. So here's the form. Capital P for permutation, a subscript on the lower left, and a subscript on the lower right. So take your red. The N tells you the total objects available. Total objects available. That's the left number. Total number of objects available. The right-hand number tells you the number of objects in each group. Number of objects in each group. Number of objects in each group. So I just did 3 total objects in a 3-object group. The N would be 3 and the R would be 3. And so if I were to write this one, it would be a P 3, 3. 3 objects in a 3-object group. So that can change, and then we'll talk about that here in a little bit. All right. Here's one thing about a permutation. If the total number of objects equals the objects in each group, you can take a shortcut. The answer to the permutation will just be n factorial. It'll just be n factorial. So this is a shortcut because of this, because the total number of objects equals the number in each group. So let me show you what I mean. In this arrangement here, we have a permutation. We have 4 total objects in a 4-object group, right? So we have 4 objects. Oops, that should have been red. We have 4 objects in 4-object groups. The first 4 tells you the total number of objects. The second 4 tells you 4 object groups. So for this one, all we got to do is punch into our calculator 4 factorial. And go ahead and do that. 4 factorial. And hopefully you got 24. So if I took Brendan and Colby and Nia and Emily, how many different ways can we arrange them in order, those 4 people, using all 4 of them? There'd be 24 different ways we can arrange them. Believe it or not, there is that many. Just think about it. Brendan in the front, then Colby, Nia, Emily, that's 1. Brendan in the front, leave Colby, switch Nia and Emily, that's already 2. Brendan in the front, then put Colby next, and then Nia, Emily, that's the 3rd. Now switch Nia and Emily, that's the 4th. Brendan in the front again, now Emily next, and then Colby, that's 5. Brendan in the front, Emily, and then switch Colby, and that's already 6. And you can do 6 for each person, 24 total. But the permutation takes care of that. All right? So whenever the total objects equal the number in each group, you can just do factorial. So again, if you see something like number 2, it's an easy problem. The answer is going to be 11 factorial. This will be a big number. Punch that out in your calculator. You'll never guess how many ways you can arrange 11 objects in 11 object groups. Say it if you got it. Yeah, 39,916,800 different ways. There is. By the way, let's say you have a basketball tournament with 4 teams. How many different orders can those 4 teams end up finishing in? 24 different ways 4 teams can end up in an order. That's the reality. All right? Permutation. Now, again, that's when the total number of objects equals the number of objects you're using in each group. What if that changes? All right, I got to get rid of my shades on higher for you guys. Come on. Come on. There we go. Come on. All right. So what if n is bigger than r? And this is the only way it will be. R can never be bigger than n. In other words, let's suppose I had 3 objects. How many ways can I arrange 3 objects in a 5-object group? None. Because how can you make 3 objects be in a 5-object group? I don't have enough. So the first number can never be less than the second number. But what if I had 5 total objects and I want to arrange them in 3-object groups? So I take 3 out of the 5 and work how many there, and then switch out one of them and work how many, switch out another and switch out another as I go through all the possibilities. That you can do. And that's the situation. All right? So what if n is greater than r? Now we have a formula. The formula is n factorial divided by the quantity of n minus r factorial. Now that's something you got to learn. You just got to learn that, and I expect you to learn that. So if you were given a problem like number 1, it would ask you, how many ways can you group 7 objects in 3-object groups? If you were doing this problem for homework, the first thing you would do is you would write this. You would write the permutation. You'd put the total number of objects on the bottom left, and you'd put the objects in each group on the bottom right, the 7 and the 3. The next thing you would do is use the formula. So somebody tell me what to put on the top. What goes on the top? Colby?
7 factorial.
Exactly, 7 factorial. Now be careful on the bottom. Make sure you use the parentheses, because the bottom is the 7 minus the 3. And when you're done with that number, then do the factorial button. So really, in effect, this is going to be 7 factorial divided by 4 factorial, right? All right, see if you can punch that on your calculator and get a correct answer. So work your calculator and see if you are getting what I'm going to tell you the answer is. Who's got an answer for me? Luke, what do you got?
210.
Okay, how many got 210? Because that is the correct answer. 210, 7. So believe it or not, if you had 7 total objects and you want to find out all the possibilities of putting them in 3-object groups where, listen, where the order matters. That's a permutation. The order matters. There are 210 different ways you can come up with 210 different groups. That's what we're talking about. Any questions so far? Big key you got to remember is a permutation, the order matters. Because on Monday, listen, we're going to talk about combinations. And in a combination, the order doesn't matter. That's the difference between the two. So again, I keep emphasizing permutation, the order matters. Okay, so here again, another problem. How many ways can you group 10 objects in 4-object groups? So again, if you were doing this as a homework problem, the first thing you'd do is you'd write the form for the permutation. So go ahead and do that, and then sub into the formula, go ahead and do that, and then get a final answer. So finish that out. Fill in the numbers on the bottom of the P, sub them into the formula next, and then get a final answer. All right? Go ahead and take that all the way to the end. And who's got an answer for me? Allison, go ahead.
5,040.
Okay, and hopefully that's what you got. 5,040 would be the final answer. That's how your homework should look, okay? That's how your homework should look. You should start out with proper notation, and then you should show the formula numbers in, and then the final answer. All right, go ahead and do one more. Go ahead and do number 3 while I do it up here. All right, and don't look up unless you really need it. Don't look up unless you really need it. Anybody have an answer yet? Emily, what do you got?
Oh, wait a second.
Who else? Luke, what do you got?
1.3 times.
Something's off on yours. Something's off on yours. Who else? Emily?
859,541,760.
Correct. 859,541,760. You should be doing 22 factorial divided by 15 factorial. Now, everybody's hand should have been up on that, so any questions? Right, that's a 22 factorial divided by a 15 factorial. Make sure you're using a parentheses on the bottom. If you don't use a parentheses, your calculator's not going to think what's going on. And again, you have to learn how to punch this into your calculator to get it to work for your calculator. So after you close that bottom parentheses, it may not like it if you put in the factorial button after that. You may have, some of your calculators, you may have to do factorial button 22 divided by parentheses, factorial button 22 minus 7, close parentheses. I don't know. That may be after the order. Or factorial divided by factorial button parentheses 22 minus 7. But you got to figure out how to use your calculator. Any questions? Okay. Well, that's what I want your work to look like. However, most calculators have a permutation button. And I'm okay with you using your permutation button, but I want you to show me the formula every time so it gets in your brain, all right? So now look to see if you can find your permutation button. It'll look like the capital P with an N and an R, usually. And those you in a menu, remember when we were looking for your factorial, it was there in your menu. So everybody look for the button on their calculator. So again, what I want you to do is, I still want you to show me the formula, 35 factorial over 35 minus 15 factorial. But let's see if we can use our button to get it. Most calculators, you do the first number, then the button, and then the second number. So see if you can get your calculator to work using the button. This is a big number. This is going to be scientific notation. And you should end up with 4.247. I'm just going a couple decimal places because this is a ginormous number, times 10 to the 21st. It's a big, big, big number. 4.247 times 10 to the 21st. And you also have to know how to read your screen when it's in scientific notation. Some of your screens, newer calculators, show you the times 10. Older calculators don't show you the times 10, they just show you the exponent, and they expect you to know scientific notation and to put in the times 10. So it depends on your calculator. Again, newer ones usually show the times 10. Older ones just show you like 4.247, etc., and then you'll see an exponent up to the right of 21. And you have to know its scientific notation and put in the times 10. So again, how do you punch that in? Usually 35, then the permutation button, then 15, and then enter or equals on most calculators. All right, calculator problems. Ashley. Oh, like I said, permutation. Okay, it's a permutation button. Yes, Juliana, hold up your calculator. Hold it up so people can see it. Anybody have a calculator similar and you found the button? It may not be on there. Not every calculator has a permutation button, which means you have no choice but to do it this way. Everybody's still going to show me that, but they can punch the button. You can't. That's the way it goes. This calculator that is now broken, this one doesn't have a permutation button. The one I lent to Brendan does have a permutation button. Okay? So not everyone does have one. All right, go ahead and do number 2. Again, remember, I want you to show me 51 factorial divided by 51 minus 4 factorial. After you do the formula a few times, it sticks in your brain. And punch that out. That one's not quite so big of a number, and you won't be in scientific notation. And Daniel, did I answer your question? Okay. So this one you got, what, 5,997,600 different ways you can arrange 51 objects in a 4-object group. Almost 6 million different ways. Because remember, for a permutation, what matters? What matters for a permutation? You got to get that in your brain. Order. The order matters. A different order is a different permutation. Each different order is a different permutation. Almost 6 million of them in that situation. All right. So, permutation button. Again, not every calculator has it, but most do, especially the newer ones. Okay, last thing. I want to show you one other alternate method of solving a permutation. So there is one other alternate method. If you treat the number as the start, and you treat the second number, the number in each group, as the number of numbers to multiply. I know that sounds funny, but I'll show you what I mean in a minute. The number of numbers to multiply. So here's what I'm talking about. You look at our, oh, come on, Windows, stop doing that. You look at our first example. I need to start at what number? 32. Now, remember, the concept is factorial. So what would be the next number? 31. And what would be the next number? Now, how many numbers do I go for? I only go 3 numbers. All right, so take your calculator. Let's do this first. Do 32 times 31 times 30. And did you get 29,760? Now do your permutation button, those of you that have the button. And can anybody confirm 29,760? Anybody get it using the button? Allison did. Edward did. So see, it's the same. So it's kind of a shortcut, little tricky way to do it. Now, it used to be calculators didn't want to do permutations with a number of objects over 99. And it used to be the only way to do a problem like number 2 is to know this alternate method. Matter of fact, it won't let you do it with the formula. So, for example, Juliana, you only have the formula. Try punching this into your calculator, guys. Don't write this. Let's do the formula. Do 101 factorial divided by 97 factorial. See if your calculator will allow you to do it. 101 factorial divided by 97 factorial. Anybody's calculator letting them do it? Edward, yours will allow you to do 101 factorial, not the permutation button. 101 factorial divided by 97 factorial. Okay, so can anybody's calculator do 101 factorial? Nobody's can, okay, because the number's too big. So, if you don't have the permutation button, you can't do it any other way. Now, let's see if your calculator will do it with the permutation button. So try 101 permutation button 4 and see if your calculator will do that. How many calculators are doing it? Okay, so almost everybody's calculator will do that if you have the button. But again, you could do the shortcut. So what would, somebody raise your hand and tell me, what would the shortcut be? Nia?
101 times 100 times 99 times 98.
And you're stopping? Why did you stop? Because there's 4 numbers, right? The 101 is where you start, and the 4 tells you do it for 4 numbers. The 101 tells you where to start, and the 4 says do it for 4 numbers. So Juliana and those of you that don't have the permutation button, that's what you're going to have to do on a problem like this. And don't be surprised if I don't ask you to show me the shortcut. Not to give me the answer, but show me the shortcut. Because I want you to learn the shortcut. Okay? I want you to know that this is another way to do the permutation. Okay? And usually I'll do it when the second number is pretty small. Because it would be a real pain to show the shortcut if it was 101p with like a 30. Then you got to do 30 numbers, and that would be a big pain. Okay? So, hold on a second. Don't pack up. Don't pack up. Please look at the screen. Let me just go through and do a quick recap here. So remember, we started this all out by talking about factorial. So if I ask you, listen, if I ask you, what does 3 factorial mean? I want you to tell me 3 times 2 times 1. But if I give you the problem of 8 factorial, I want you to tell me 40,320. Okay? I will ask you what it means because I want you to know what factorial is. Once we knew factorial, we can do permutation, and don't lose the fact that permutation means the groups in a specific order. Meaning changing the order gives you another permutation, another possibility. So we're figuring out how many possible ways you can arrange objects in a certain amount of group. Don't lose the fact of the shortcut. If n and r are the same, you can just use the factorial button. A permutation for 4 is just 4 factorial. If you're doing homework, what would your homework be? Just this. P1111, all you got to show me is 11 factorial and the answer. That's all you got to show me. But show me the 11 factorial, right? When you get to the full formula, when n or r are different, then remember you're going to show me the formula with the numbers in it and then your final answer. You can skip that step if you want to. I'm okay with that. Okay? Now, if they give you a word problem, you're going to show me the permutation symbol, right, with the n and r numbers. Show me that because you want to get used to that. Any questions, anybody, on any of these? Okay, you can pack up now, or if you got a little bit of time, you can get started on your work.